evaluate the indefinite integral. So here we have x over 1 plus x to the fourth dx. So in this particular problem, what we want to do is try to find something that we can sort of match with something that we've done before. So what we can do is, looking at the denominator, we have 1 plus x to the fourth. Okay? And so in this particular problem, what we may want to do is rewrite this in terms of a square. So what I mean by that is, sometimes we can manipulate the original question. So we have x over 1 plus, here we have x squared dx. Okay, so what we can now do is now replace u to be x squared so that it matches something that we've seen before as far as our antiderivatives. So we're going to let u equal x squared, and then step 2, take the derivative of both sides with respect to x. So du is going to equal 2x dx, and then we're going to divide both sides by 2, and therefore we get 1/2 du, which is equal to x dx. Okay, now with step number 4, we're going to rewrite this statement. So the statement is going to be the following. We're going to have 1 over 1 plus x squared times x dx. So what do we know about the denominator with 1 plus x squared dx? We know that x squared is equal to u, so that's 1 plus u squared, times, we know that x dx is equal to 1/2 du. So now we're going to factor out the 1/2. And now we have 1 over 1 plus u squared du. Okay, now what do we know about 1 over 1 plus u squared du? Well, we know that that represents the tangent inverse of u. So therefore, this is going to equal 1/2 times the tangent inverse of u plus c. Okay, and so now what are we going to replace u to be? We know that u is the following. We know that u is x squared. So therefore, our answer is going to be 1/2 times the tangent inverse of x squared plus c. And therefore, there is our result.